Hello, welcome back. This is a new chapter, and this is chapter 3, and we're going to be talking about systems of equations. And so what we're going to do in 3.1 is we're going to solve systems graphically. All right, so what we want to do, a system of equations, we can go through this. It's a set of two or more linear equations that are solved simultaneously. Okay, a solution to a system of linear equations, the point or points that satisfy both equations. Graphically, this is where the two lines intersect, the point at which they intersect. So here's what I've got. I've got line 1, okay, that I'm going to put in red. So line 1, and I'm just going to draw that here, all right? And this is going to be some graph, all right, some line. Okay, it doesn't matter what it is. I'm not really concerned about that. But then let's look at another line, line 2, okay? So this line, and we'll just call this intersection point right there. All right, so you got these two lines. And what we're looking for is where do these points intersect. Okay, so here's line 2, here's line 1, okay, and then this is my solution. Okay, and if I were to, actually name this solution, this is the point 1, 2, 3, 4, 5 up 2. So this would be the point 5, 2. Okay, so graphically what we're looking for is the, when we're talking about the solution to a system of linear equations, we're talking about the point where the graphs intersect. Okay? All right, and we're looking for that value to be an x value and a y value. Okay, and we'll learn how to do this algebraically in the future, but for right now, we're just going to do graphically. So let's talk about a couple of different types of solutions. So we have 3 types of systems of linear equations. Okay, we have what's called a consistent and independent system. Okay, I like to call that a system that has one solution. Okay, and that's just two lines that intersect. Okay, and we have my one solution where they intersect. Okay, and what I know about these lines is the slopes of these lines are different. Okay, how many solutions? We have one solution. Okay, and we would write this solution in the form of x comma y. All right. Now, if we were talking about something that's inconsistent and independent, that would be something that has no solution. Okay? No solution. All right, so what I would do is these would be lines that are going to be parallel. All right? So these are lines that never touch. All right? So they don't intersect. So don't intersect. They are parallel. Okay, parallel lines, never touch. Okay, so the lines never intersect. The slope of these lines are the same. Okay, and that's how I know that they're parallel. Okay, the y-intercepts of these lines, they're different. Okay, how many solutions? We have no solutions, none. Okay, and if we were to write this, we would simply write no solution. Okay, or we would write what's called the empty set. You can do the 0 with a little line through it. But I just write no solution. That's all I really care about. Okay, the last type of equation we have is what we call consistent and dependent. Okay, and what that means is that we have an infinite number of solutions. So infinite solutions. Okay, and what that means is that we have the same line. All right, so if I were to say draw some sort of line like this, and let's say we had another equation that we drew the line for, and I draw it right on top of the other one, okay, then what I'm looking for is where did these two lines intersect? Well, I have an infinite number of points along this line that intersect, okay, and that's the idea, is that you have infinite solutions when you have the same line. Okay, so the slopes of these lines are the same, okay, and the y-intercepts of these lines are the same. How many solutions? Infinite. Okay, and if we were to write this, I would just write the words infinite solutions. All right, and I would just keep it at that. I wouldn't mess with it. Okay, let's not make this harder than it needs to be. Okay, and here's a little bit of stuff about set builder notation, and we'll kind of talk about this as we get, talking more about domains and stuff like that. So let's go ahead and move on to the next page. All right, so let's go over some examples of what this is going to look like. And I've went ahead and provided you guys with some graphs here. And so what I want to do is graph both of these equations on the same graph. And then I want to find out where they intersect. Okay, so here's the steps that you do. Graph each line on the same Cartesian plane. Locate the point or points of intersection, and then this will be the solution. All right, so let's go over here and let's talk about these first two equations. Now, whenever you see a system, they have these brackets over here on the left to include both of these equations, and that indicates that you have a system of equations. All right, so the first things first, I'm going to label this one. I'm going to rewrite it as y equals negative 2x plus 3. Okay, now the slope, all right, both of these are in y equals mx plus b form, which is nice. We can just go ahead and just graph it as we see it. The slope of this first line is equal to negative 2 over 1, and my y-intercept is equal to 3. So b is equal to 3. All right, and my second one, the equation y equals 3x minus 2, my slope of this is going to be 3 over 1. Now I'm writing it over 1 when I write my slope, just so I know what my rise and run is, okay? So just so I don't get confused. And then my y-intercept, so my slope is here, y-intercept here, so b was equal to negative 2. All right, so let's go ahead and just graph both of these on the same graph. So I'm going to come over here and in red, okay, I got to remember this, y-intercept of 3, slope of negative 2, so let's go over here, y-intercept of 3, and then I'm going to go down 2 to the right 1, down 2 to the right 1, okay, and kind of repeat that process. And I do this when I graph these solutions just because I want to make sure I have a specific point, because sometimes when I draw my lines aren't exactly straight, but if I'm connecting them with these points, it's a little bit better. So, okay, graph that one, all right? And then let's go over and graph the other one, and the slope was 3, y-intercept was negative 2. So here's negative 2. Okay, and I'm going to go up 3 over 1, and check this out. There's my intersection point right there. All right, and so I can go ahead and just plot those points. So that intersection point is important. Okay, so we got to write that down. We write down the point 1, comma 1. That's the point on the graph where they intersect. Okay, so this is my solution. Okay, and I know that, x is equal to 1 and y is equal to 1. Okay, all right, so look at the next one. See what happens with this. And, what I've got with these two equations is that they're both in standard form, okay? And they're not in slope-intercept form. So what I can do is I can kind of quickly do these and rewrite them and solve them for y. So let's look at my first one. I've got 6x minus 2y is equal to 2. I'm going to solve this equation for y. So I'm going to subtract 6x from both sides. All right, so I've got negative 2y is equal to negative 6x plus 2. Then I'm going to divide everything by negative 2. Okay? And so I get that y is equal to positive 3x and then minus 1. Okay, so this equation, guys, is the same thing as this one I had here. I solve this for y, and all of a sudden I can identify my slope, which is going to be 3 over 1. Okay, and then my y-intercept, which is going to be negative 1. Okay? And so that's why I do that. For me, it's just a little bit easier. If you want to graph it and check points and do the y-intercept and x-intercept thing, you can do that. But I'm not requiring you to do that. So let's go ahead and take a look at the next one. Okay, 9x minus 3y. Let me write this one down, and that's equal to 1. And I'm going to go ahead and solve this one for y as well. So I'm going to subtract 9x from both sides. Okay, this cancels out. I get negative 3y is equal to negative 9x and then plus 1. Okay, and then what I have, if I divide by negative 3, divide by negative 3, and divide by negative 3 here, I get y is equal to positive 3x and then minus 1/3. So what I want you to notice here is that both of these lines have the same y-intercept, or I'm sorry, the same slope. So my slope here is going to be 3 over 1. My y-intercept is going to be negative 1/3. That's okay, I can have that, all right? No big deal in that. But, you know, the issue is, because these slopes are the same, this is automatically going to be no solution, okay? They're going to be parallel lines. Parallel lines have the same slope, all right? Parallel lines have the same slope. So if you do that, and you can kind of already do that before you graph it. You don't even have to do anything. So let's go ahead and graph the first one. And so I'm going to go here. I know my y-intercept is negative 1 and my slope is 3. So I'm going to come over here, plot negative 1 and have a slope of 3. So I'm going to go up 1, 2, 3 over 1. Okay, and I'm going to draw that line again. Okay, now this, because I already know what my solution is going to be, I don't really need to be that particular about it. But let's go in and then graph the other one. This has an intercept at negative 1/3. And then it's just going to run directly next to, and I know it doesn't look good, but they're never going to touch, okay, because these lines are parallel. All right, so I'm going to write that in there again. Lines are parallel. They do not intersect. Do not intersect. All right, and we'll be able to kind of tell that just from just looking at our equations. All right, for the last one, let's go ahead and take a look at this. Now this has B and A. Now what I want to do, A is like my x value, B is like my y value, okay? So this one is already in slope-intercept form, okay? So I'm going to rewrite this as B is equal to negative A plus 3. Now I can rewrite that and switch it around, okay? And the reason why is because I want to identify my slope. My slope M is equal to negative 1. My y-intercept B is equal to 3. All right. Now, if I take this equation down here and solve this for B, let's see what I get. Okay, now I'm going to go ahead and take this. I'm going to rewrite it. 2A plus 2B is equal to 6. So if I subtract 2A from both sides, all right, I'm going to get 2B is equal to negative 2A plus 6. Then what I want to do is I want to divide everything by 2, okay, and see what divides out. So 2 over 2 divides out. And I get B is equal to, okay, negative 2 divided by 2 gives me negative 1. So negative A. And then 6 divided by 2 is going to give me 3, so plus 3. So what I notice is that I get the same thing as I did up here. Okay, and so I get a slope, M, that's equal to negative 1. I get a y-intercept B that's equal to 3. All right, so since we have the same thing, what we're going to have is we're going to have infinite solutions. Okay, we have the same line. Infinite solutions, we have the same line. All right, so now what I want to do, let's go ahead and just graph these. All right, we have a y-intercept of 3. I'm going to do the first one up here is 3. And then a slope of negative 1. So down 1 over 1, okay, goes in this direction. All right, so draw that. And then what I want to do is draw the next one, y-intercept of positive 3, slope of negative 1, and it's going to go in that direction as well, okay? And so because, these lines are directly on top of each other, they have an infinite number of intersection points, okay? And that's because they're the same line. So that's all I got. This process isn't too difficult. As long as you understand how to take equations, put them into slope-intercept form, and then graph them from there. So I hope you enjoyed the video. Had a lot of fun making it. We'll see you next time. Bye!